Hi there, it is Mrs. Tremblay, and I am here with lesson 12.1, and today's topic is square roots. This whole chapter is about irrational numbers and square roots. So today you're going to kind of learn how to undo squaring something, which essentially is finding the square root. So first, a little review, because it's going to help us with what we're doing in just a moment, of what it means to square a number. And I have 1 squared through 12 squared here. And just a reminder, 1 squared does not mean 1 times 2. It means 1 times 1. Do you have to write that? Yes, you have to write that. So write 1 times 1, and it equals 1. And circle that answer. And 2 squared, yes, it means 2 times 2, which is 4. 3 squared doesn't mean 3 times 2. It means 3 times 3, which is 9. So go ahead and write out your multiplication problem with your answer. I'll continue writing mine. Circle those answers so they're easy to find. And there is a reason I'm having you do this, I promise. So bear with me. 9 times 9 is 81. 10 times 10. 11 times 11. And 12 times 12. Alright, now what we have here are a bunch of perfect squares. That's what I call it. And if you think of a square, just the shape, squares have the same side lengths, right? So if you're finding the area of a square, you take length times width. So they call this a perfect square because squares have to be perfect. One side length has to match the other. So anyhow, enough of those factoids. One good thing for you to do is to memorize these. It's going to make today's lesson go by a lot faster and easier. Or the application of today's lesson go by that a lot faster if you know those and have them memorized 1 through the 12. All right, so what we're going to learn how to do next is to undo squaring a number. And just kind of think back to what you learned back in the day. You learned the opposite of addition is subtraction. So to undo addition, you can subtract. To undo multiplication, you can divide. Well, now to undo squaring a number, you can find the square root. And that's what this little paragraph here is talking about. So to undo squaring a number, you take something called the square root. A square root of a number is a number that when you multiply it by itself, it equals the given number. Now, these numbers that you're trying to find the square root of are going to be written, and they're going to look like this. They're going to be underneath what I call, this is a radical sign. Not making it up, really is called a radical sign. The number inside is called a radicand. So the symbol is called a radical, and the number underneath that radical sign is called a radicand. So basically, this represents finding the square root of 1. So I want to know what number multiplied by itself will give me 1. And this is where that little list that we have up top will help us. So for example, if I know up here that 1 times 1 is 1, that means the square root of 1 is 1 because 1 squared is 1. This will make more sense in a little bit. So just say 1. And the reason it's 1 is because 1 squared is 1. Alright, for 4, the square root of 4, I'm asking you, what number squared would give me 4? Okay, so up here, do you see how 2 times 2 is 4? The square root would be 2 because 2 squared is 4. So it's basically whatever the base is. So with the square root of 4, we're going to say 2. And again, the reason being is because 2 squared equals 4. So whatever that base is, that's the square root. Okay, with 9, and maybe you're seeing the connection up here, it's going to end up going right in order here. I have 1, 4, 9, 16, and I have here 1, 4, 9, 16. So the square root of 9 is 3. And it's 3 because 3 squared is 9. The square root of 16 is 4 because 4 squared is 16. The square root of 25 is 5. 36 is 6. 49 is 7. 64 is 8. So again, in order to get those digits, all I'm asking myself is what number can I multiply by itself to get the number inside? Alright, 9 times 9 is 81. 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. So hopefully you see that if you do have those squares memorized, the 1 squared through 12 squared, when you're dealing with problems like this, you're able to go ahead and recall what the square root would be. All right, so a couple more little things about this, and then we'll get into some evaluating. Every positive number has a positive and negative square root. A perfect square is a number with integers as its square roots. The examples on the previous page, well, these examples up here are all perfect squares. So it says a perfect square is a number with integers as its square roots. Integers are positive or negative whole numbers. Okay, so perfect square is basically if you can take a whole number and square it, no decimals, all whole numbers, then you're good. Up here it says every positive number has a positive and negative square root. For example, think about it this way. If I asked you what the square root of 100 is, we already know that it's 10, right? And we say that it's 10 because 10 squared is 100. But what's negative 10 squared? Isn't negative 10, the quantity of negative 10 squared, also 100? That means that the square root of 100 could be a positive 10 or a negative 10. So I want you to know when I'm asking you for positives and when I'm asking you for negatives. And that's listed right here in this little chart. So basically, if I want you to give me the positive version of the square root, I'm not going to do anything. It's going to look just like the examples above. Square root of 16, that means just give me the 4. If I throw a negative sign in front of the radical sign, then you guessed it, this means the opposite of the square root of 16. That means give me the negative version. So instead of 4, this would be negative 4. And if I ever want both of them, and next year when you deal with quadratic equations and quadratic functions, yes, you will deal with this. We talked about that in class. But basically, if I want both, you can just put this little plus minus symbol right here, and your result, your base right there. Okay, so if I want just the positive root, it's going to look just like the radical sign with a number inside. If I want the negative version of it, there'll be a negative sign outside of the radical. And if I want both, you'll see an addition and a subtraction sign to represent both. Give me the positive and the negative version of it. All right, turn your page. Now for some evaluating. Okay, so we have been talking about order of operations, I think, forever and ever and ever. So let's review and talk about it some more, because what fun would it be if we didn't talk about it again? Okay, so when you evaluate expressions with square roots, and if you kind of think back, maybe you're like, why are we talking about order of operations again? When you first learned about order of operations, didn't you basically just learn that multiplication and division happen before addition and subtraction? Because you didn't see parentheses or anything yet. And then eventually you added those parentheses to it. And then eventually we added exponents in there once you learned about exponents. Well, now that you're learning about radicals, you have to know where they fall in the whole chain of command here, or of operations is the chain of command. So exponents and radicals are just like multiplication and division. They happen kind of at the same time from left to right. So whenever you see something that's underneath that radical sign, I'm asking you to take the square root of it, that happens second. The first thing is still the groupings, whatever's inside any of those symbols. Then exponents and radicals happen from left to right. Multiplication and division left to right, addition and subtraction from left to right. So let's try it. We're going to evaluate each expression, and just a reminder to please write down all of the steps along with us. All right, so step 1 says we're supposed to do anything inside a grouping symbol, and I don't see any. Step 2 says exponents and radicals. So that would be this square root of 36 right here. Now you know how when a number is next to parentheses it means multiplication? When a number is next to a radical sign it means multiplication. So the square root of 36, yep, if you memorize 6 squared is 36, then you know the square root of 36 is 6. So I'm going to replace that square root of 36 with 6, put that multiplication sign now between the 5 and the 6, and add our 7. Next step, we have to multiply before we can add, so 5 times 6 is 30, and 30 plus 7, yes, is 37. All right, slide it over. Remember that I told you not to keep change until after you took care of exponents. I would recommend that you don't keep change until you get rid of those radical signs too. So let's start off with this square root of 25 because there aren't any groupings and there aren't any exponents. So 12 minus 3, and 3 is next to that, so I'm going to multiply. The square root of 25, what number squared is 25? 5 is. And now we can go ahead and keep, change. Reminder, you cannot do 12 plus negative 3. You have to multiply first. So you're really taking 12 plus negative 3 times 5 is negative 15. And now we're left with negative 3. All right, moving right along here. Okay, this time I do have some parentheses, so I'm going to bring those down. Within those parentheses, I have a radical. The square root of 49, it's 7, because 7 squared is 49. Once the radical's gone, I'm going to keep, change it. So now I'm left with 5 times 7 plus negative 10 would be negative 3. And 5 times negative 3, you guessed it, it's negative 15. All right, the last one, I always save the most confusing one for last, don't I? When you look at this, like, you can't take the square root of 28, you can't take the square root of 7. Those aren't perfect squares. There's not a number I could multiply by itself to get 28. And there's not a number I can multiply by itself to get 7. However, I know that 28 and 7, though, you can divide those, right? So when you see this, when there's a division problem underneath that radical sign, take a look. Check to see if there's any perfect squares, because then you could pull those out of there. But see if it's divisible. 28 is divisible by 7. It's 4. But we didn't take the square root out of that. So I'm going to put the square root sign over top of the 4. So 28 divided by 7 is 4. I am supposed to take the square root of that. The most common mistake is people just bring down 4 and forget to take the square root of it. So don't let that happen to you. All right. Well, the square root of 4 would be 2, because 2 squared is 4. And I'm left with 2 minus 7. Now to keep, change it. 2 plus negative 7 is negative 5. And we are done. See ya.